In this video, I want to walk you through the steps for hypothesis testing, which is in our third module. And our focus today is going to be on just the steps. And the steps are virtually the same for any kind of hypothesis testing that you do within statistical research. So in the first step of hypothesis testing, the first step is you should always state the two contradictory or opposite hypotheses. So there are two of them, and a couple of things I want to point out to you. One is that a hypothesis, and hopefully you can kind of relate this to science, a hypothesis or hypotheses is basically an educated guess. If you think about it in the context of statistical research, remember that statistical research typically begins with a question. And when we have a question, oftentimes we also have kind of that answer in the back of our mind, or at least what we believe the answer to be, or even want the answer to be. And so we then use statistical methods to determine whether our kind of gut instinct or our guess is valid or invalid. You can sort of think about it, a hypothesis test similar to a court case, where a person is considered innocent until proven guilty based on the evidence. So a hypothesis test lets me determine whether my hypothesis, educated guess, is good or bad, valid or invalid, based upon the evidence that we get from the sample. The first hypothesis that we deal with is the null hypothesis. And the null hypothesis is a statement about a population parameter that contains equal in some form. And I think it'll be easier if I just leave it where I can write on the screen here. Notice that it says it is a claim about the population parameter. So we can make a claim about the population mean, the population proportion, the population standard deviation. There are lots of different parameters. Our focus in terms of that population parameter is going to be on the mean, and specifically on one mean, because you can also conduct a hypothesis test with two means. There's also a procedure where you can look at three or more means. So we're going to focus on the population parameter of the mean. And remember, we use Greek letters for the population. So our Greek letter for the mean is mu. And the other key statement here about the null hypothesis is that it contains equal in some form. And so if you look here down at the bottom of the slide, you'll see your options. So it could contain equal. It could have greater than or equal. Oh, excuse me, that's less than. Looked at it incorrectly. Give me just a second. Okay, so it could be less than or equal. Or finally, it could be greater than or equal. And so those are the three options that you have in terms of stating your null hypothesis. The other key thing that's important about the null hypothesis is that the null hypothesis is assumed to be true throughout our hypothesis test, just like a person is assumed innocent until proven guilty. So if you think about it as a court case, an individual is assumed innocent until proven guilty or proven otherwise. Okay, so the same is true with the null hypothesis. The null hypothesis is assumed to be true unless we prove otherwise. Okay, the second hypothesis is called the alternative hypothesis. And again, it's still going to be a statement or a claim about the same population parameter. So even the alternative hypothesis deals with the population parameter, and it's the same population parameter that you would have had for the null. In our case, it's going to be a mean in one of them. And it is the exact opposite of the null hypothesis. And the key thing about the alternative hypothesis is it will never, ever contain equal. And again, if you look down at the bottom of the screen at the table, you'll see that, okay? So the opposite of equal would be not equal. The opposite of less than or equal is greater than. And then finally, the opposite of greater than or equal is less than. And guys, these are always paired in this manner because, again, the null hypothesis and the alternative hypothesis are inverses of each other. So equal will always pair with not equal. Less than or equal will always pair with greater than. Greater than or equal will always pair with less than. And oftentimes that's one of the challenges for students is knowing which one of the symbols should be used. And so that's all in the phrasing of your scenario. Okay, the other thing about the alternative hypothesis, and we're going to talk more about this in just a minute, is it determines the type of test you're going to do. And we're going to talk more about that in just a minute. But on the next slide, I put together a list. It is not comprehensive. It doesn't include every possible phrase, but it does give you an idea of some phrases that you might see in the scenarios that you're going to be dealing with to let you know when you should use greater than or less than, equal, not equal, and so forth. So that particular table or graphic might be helpful to you as we continue through this discussion and we get into looking at examples. So to go back to that idea of the type of test, the type of test is determined solely by the symbol in the alternative hypothesis. And that's important because the calculations that are performed, whether you're doing it by hand or by the calculator or by the free website, are affected by the type of test, whether you have what we call a one-tailed test or a two-tailed test. Since we're dealing with the mean, and we're going to focus on specifically what is called the one mean Z test, our test itself is based on the normal distribution, which, if you'll recall, you have your horizontal baseline, your bell-shaped curve with the mean in the middle. And so if you think about it and you're trying to find values that are less than the mean, values that are less are going to be on the left-hand side. If you think about your number line, they're on the left-hand side. So I would have this region over here where we would have an area where we can make the distinction between whether our hypothesis is good or bad. And it's on the left-hand side, and we only have one option. Hence, the term one tail, because I only have one option. It has to be less than. It's sometimes referred to as the left tail test because that cutoff is on the left-hand side. Similarly, if you think about it for greater than, again, you still have your horizontal baseline, your bell-shaped distribution with the mean in the middle, but this time you want to be greater than. Well, greater than, numbers that are greater than are going to be to the right, so that's going to be on the right-hand side. And again, at some point you'd have this cutoff between whether your hypothesis is good or bad. And so notice that's on the right-hand side, but there's only one option. It's only if it's greater than. So again, we call that a one-tailed test, and some texts will refer to it as a right-tailed test. And then finally, the third one we call a two-tailed test, when you have not equal. Because if you think about what it means for something to be not equal means that it could be less than, or it could be more than. The whole idea of not equal just means it is not the same. Okay, so when you think about it in the context of not equal, again, you have your baseline, your bell-shaped curve with your mean in the middle. And so we're thinking it could be less, so there'd be a region on the left side or below the mean, or it could be more, which means you have this region on the right side. So you have two different options because it could be less or it could be more. Hence the term two-tailed. And so you need to be able to make that decision early in the process because it's going to affect your calculations. I know in the calculator you have to enter which type test you have, and also in the free website. Okay, so then we move on to step 2. In step 2, in the real world, you would actually go out and collect your sample data and then determine your descriptive statistics, perhaps using the Calculator Soup website, using your calculator, using some sort of statistical software like Minitab. But for our purposes, you're going to actually be given this information in the scenario. So you have to simply identify the information that you have in the scenario. So this may mean that you have to read your story or your scenario through several times. But typically, the information is given in such a way that it's reasonably obvious what value is what. There are 5 pieces of information that you want to identify. Those are, first off, the population mean, which is on your calculator is mu with a little subscript of 0. And notice that the population mean is the value that you have stated in your hypothesis. You need the population standard deviation. That's the big clue here, that we want to use the z-test. Okay, the fact that you know the population standard deviation is the big clue that we're going to do the one mean z-test. We're not going to cover it at least this semester, but there is also a hypothesis test called the one mean t, as in tiger, test. And the difference is if you do not know the population standard deviation, then we would normally use the t-test, much like we did with the z-interval and the t-interval. Okay, so knowing the population standard deviation is the big red flag that says do the z-test. You should also be able to identify your sample mean and your sample size, and then also be able to identify your level of significance. It's represented by the Greek letter alpha. That's the Greek letter alpha. It's the one that looks like a little fish. It's called the level of significance, and it's usually presented in decimal form. And basically what it boils down to is the level of significance is the probability that you're going to make a wrong decision. Previously, we talked about earlier in the module, we talked about the confidence level. The confidence level, if you'll recall, is kind of the probability that we're going to make the correct decision. How confident are we in our answer? And it was typically stated as a percentage. We would say, I am 95% confident, or I am 99% confident. You could also see something like 90%. So you have the confidence level, which is the probability that you're correct. And the opposite of that is the level of significance, which is the probability that you're wrong. So if you think about your level of significance as it relates to the level of the confidence level, you would have this idea, okay? So my alpha, if I'm 95% confident, then remember the probability has to total to 100. That means there's a 5% chance that I'm wrong, and normally that's written as a decimal, which would be 0.05. If I'm 99% confident that I'm correct, then there's a 1% chance that I'm wrong, which is 0.01 as a decimal. If I'm 90% confident, then there's a 10% chance that I'm wrong, and that's 0.10. So that's kind of the difference. So the level of significance helps us to know, again, the probability that we're going to make the wrong decision. And that level of significance can be determined by the researcher. They can set it at typically 5%, 1%, or 10%. Or they can leave it open-ended, and then you as the audience can decide whether or not the results are significant enough, and decide whether you should, if your hypothesis is good or bad. Okay, so all of that's given in your scenario. You're simply going to identify them, okay? And you may want to make a list of those and write them down as you're going through this scenario. Step 3 is we're going to actually calculate and write down our test statistic and the corresponding p-value. Now, personally, at this point, I would recommend that you use the free website. It's a little bit more user-friendly than the calculator, but you do have the option of using the calculator. And at this point, what we're doing is this is sort of like gathering the evidence, okay? Based on what we've learned about this small group, how does that relate back to the large group? And then is our hypothesis good or bad? Is it valid or invalid? Okay, so we use the information that we've collected in step 2, and we're going to calculate that test statistic. Again, for us, we're going to be focusing on the one mean z-test because we know the population standard deviation and or the sample size is greater than or equal to 30. And as I've mentioned before, that z-test is based on our normal distribution. And it's not just willy-nilly. You don't just calculate it and automatically say, well, okay, there's very little subjectivity here because we're going to relate it back to what's called the p-value and whether or not our test statistic is what we call statistically significant. And I got to talk a little bit about some theory here to kind of get you to, that maybe help you understand what we mean by the idea of, is my value statistically significant? So I want to talk about that for just a minute. Okay, so statistically significant, if you look at the formal definition, it says a test statistic is said to be statistically significant if it is far enough away from the presumed value of the population parameter to conclude that it would be unlikely for the sample statistic to occur by chance if the null hypothesis is true. And so basically we're saying, is the test statistic different enough to the point that we can conclude that it's an unusual occurrence? And so really what we're looking for is if we take one sample and get a test statistic, and then I go out and I collect another sample, how likely is it that I'm going to get that same test statistic again, or a test statistic that's reasonably close to the one I had? And if I continue to do that over and over and over again, how likely is it that I'm going to consistently get a value that's close to that particular test statistic over and over again? The value for that, determining the probability that that particular event's going to keep occurring over and over again, is called the p-value, which actually stands for the probability value. It actually stands for P in this abbreviation, stands for probability. Now, formally, it really means it's the probability of a type 2 error. Okay, but that probably doesn't make any sense to anybody. So it really means it's the probability that you're going to get the test statistic over and over and over again, assuming the null hypothesis is true. Okay, so again, it's the probability that that same test statistic is going to occur over and over and over again for different samples, okay, assuming the null hypothesis is true. And again, typically your p-value is going to be expressed as a decimal. And again, it actually relates to the normal distribution and the amount or the area under the curve in relationship to your test statistic. But again, the calculator or the computer is going to do those calculations, or the statistical software is going to do those calculations for me. So I think it'll make more sense when we start putting some numbers in there. Once you get your test statistic and your p-value, then you're going to draw a conclusion. And to draw a conclusion, we're going to actually compare the p-value, which we get from our calculator. So the p-value is going to come from the calculator or the free website or our statistical software. So that's going to come. We're going to be ultimately given that. And our level of significance is definitely given in the problem. And so ultimately, if you think about it in terms of a court case, okay, we know that there are two scenarios. Typically, in a court case, a person can be guilty or not guilty. So if you think about it here for a minute, again, we assume a person is innocent until proven guilty. Okay, we assume a person is innocent until proven guilty. So if we have assumed they're innocent, and we reject the hypothesis, this would be like saying that person or the individual is guilty. And in that case, we're saying that our hypothesis is a bad one, or that it's invalid. That our hypothesis is false. On the other hand, other option or the other phrase is that we fail to reject the null hypothesis. And so this would be like saying you fail to reject. That's like saying the person is not guilty. And that our null hypothesis was a good one, or that it was valid or true. But again, I want to point out here another phrasing. Within the court system, we either say guilty or not guilty. We don't say guilty or innocent. Okay? And so notice the phrasing, we fail to reject the null hypothesis. We never use the word accept. Okay? We never use the word accept. Because We fail to reject it based on the evidence that we have, or we find an individual not guilty based on the evidence that we have. If we had different evidence, we might come to a different conclusion. Okay, so just be careful of your phrasing. The other piece here is, how do you know when to reject and when to fail to reject? And I have it written out in words here. It says if the p-value is less than or equal to the level of significance. So in other words, if p is less than or equal to alpha, you're going to reject the null. Every time, all the time. For fail to reject, it says if p is greater than alpha. So if p is greater than alpha, we fail to reject the null every time, all the time. Okay, so it's simply comparing your p-value that you get from your calculator or your website to the level of significance. And that's going to determine whether you reject or fail to reject. And then finally, we want to go back and state our final conclusions in terms of the original claim. Okay, that's important. You also, I don't have it listed here, but you also want to, when you're writing your final conclusion, you do want to include the level of significance. But you want to put it back in terms of the context of the problem, okay, and not use a bunch of math symbols and stuff, because, you know, somebody just that walks in off the street is probably not going to be familiar with those particular symbols and things, and so you want to put it back into a good old basic everyday English sentence. And we're going to take a look at some examples. I want to show you an example of each type of scenario that you can have: equal, less than, and then greater than or equal to. And so we're going to do that in a separate video. But this kind of gives you an idea of the steps or the process that we're going to be following as we go through and talk about hypothesis testing, really for the rest of the semester.